Hello, today I would like to show you some setup hints of the Plug.n.DAQ Lite device. From time to time it happens that customers don't need at one channel or at both channels the IEPE sensor supply. So for this reason it is possible to disable the sensor supply after you open the housing and remove the PCB. This is, the PCB. You can remove here a jumper from the PCB. So in this case, the IEPE sensor supply is disabled. So if the IEPE sensor supply is enabled, then first the LED is red. So here I have an IEPE accelerometer mounted on vibration calibrator. Now I connect the accelerometer to it. So now everything is okay. And the LED go off because the current and the cable and everything is okay. The Plug.n.DAQ Lite unit is detected by the PC as a USB audio codec. So here I choose the 2-channel audio device, and here we can see the Plug.n.DAQ Lite. Of course you can have on the PC system also another sound cards or another sound devices, but the Plug.n.DAQ Lite is detected here as a USB audio codec. Here with the NVH Analyzer software you have two selection menus, in this case for impulse hammer measurement or for vibration, odor analysis and acoustics measurement. So we choose here now the second option. One crucial factor is if we want to measure with several sensors and we want to get the output also level related, so to the engineering units, means we have to take care. So I go here to exit this first. We have to take care about the sensor sensitivity and the range input of the Plug.n.DAQ Lite device. So the range input of the Plug.n.DAQ Lite device is mentioned here at the back side of the device. So in this case I have here a range input of 5 volt. This 5 volt must be noticed here. So I have here an accelerometer, it's called KS77C10, means it could have 10 millivolt per G sensitivity. So I just leave it as this, and usually if you have the accelerometer, so then you can use from manufacturer the calibration sheet and just key in here the related sensitivities which are on manufacturer's data or calibration sheet mentioned. Another possibility is to determine the sensor sensitivity using calibrator. This is what we will do right now here. So I click to the calibration menu. So the calibrator delivers 1G RMS at 159 Hertz. So now I activate the calibrator, start the measurement, and here I can see already the output of the sensor sensitivity. Now I calibrate it. So here we have the current calibration factor, and before it was mentioned 100 millivolt per meter square. So this is now done. This calibration value is here copied to this menu, and I can save, of course, this settings. So if I want to have the calibration result in G, then I can choose here G. Again, calibration menu, start calibration. So now we can see here that the amplitude is now calculated here in millivolt per G. So means the sensor have a sensitivity of 10 millivolt per G. Now I can again execute the calibration. So this is done. With this calibrator I can change also the frequency, for example. So now I see that at 1 kilohertz I have 9.9 millivolt sensitivity per G. Here it is again noticed. I save it. So, and this is done. In the Analysis menu, I can change or set up several properties like FFT line resolution or FFT averaging, linear or peak hold, or FFT waterfall analysis. So if I want to determine during the measurement a maximum peak value in the narrowband FFT, then I need this option here. So here I can get the overall values, the acceleration, the velocity, and here the displacement in micrometers. Depends on number of channels. I can select here the related values which I want to see. For example, it's a channel number 2. If I would have now a microphone, so then I could choose this values, but I don't have now. Okay, one thing I forget. Some customers use at the channel number 2, for example, a RPM signal. So then if we click this here, then we get a lot of additional options which are related to the rotational vibration analysis topic. So now we can start with the measurement. Here we see now our signals. I can change the frequency now to 80 Hertz or 160 Hertz. So here in this 4 windows you can set up by yourself how and what kind of analysis you want to see. So for this reason we can change here the display properties. For example, now I would like to have just 2 displays from channel number 1. So then I use this setup. So I have here the time domain level velocity, but I would like to have the acceleration. So and at channel number 2 okay, the signal. So now I can save this graph. And sometimes during the measurements we want to see and we want to get more informations so that we can switch quickly through different graph displays. So in this case I can prepare here different graphics and then load here. So now 2 graph. This is what I just created. So now I have prepared here 3 different layouts. I save this. And now I can start the measurement. So now my signal 160 Hertz, and here I can switch to the next graph. So this is now the pure analysis function. It is so I recommend anyway to record the raw data, and for this reason we can activate the record function. I create a new name now play the measurement and start the record. So another possibility is using the trigger recording. So means I can determine here my trigger channel is number 1 and I would like to, the trigger threshold is, let's say, 0.6 G and a pre-trigger time of 1 second. And the recording time should be, let's say, 4 seconds. So now I create new file name and say OK. So now I start the measurement. So and now trigger, the automatic and unattended trigger recording should work. So after we record our datas, we can load the raw datas. Here we can see already several recordings. We can load the datas and then we can export this datas to the CSV format. So the export is done. In this case, you can use another programs to import the datas and, for example, Excel, and continue with your presentation. Thank you very much for your attention. I wish you a pleasant day.